on this computer. Okay, so if Martin and Alex, if you're okay, we're basically recording all of the Zoom sessions, just because there's one or two colleagues who may not be able to join. So just to remind everybody where we are, on Monday we started with the introductions, we framed the week, we have the learning objectives for the week. We then did a session on theory of change, essentially putting your research into the context of why you're doing it, what it's for, what it's aiming to achieve. We spent Tuesday, the bulk of the day, thinking about how we implant and embed ethical behaviour and responsible innovation into that process. We had a session at the end of the day with Anne talking about the nuts and bolts of how you're going to actually manage and deliver your research. Yesterday we had the 4 sessions, which were essentially taster sessions around research methodologies or research philosophies, if you like. I really do encourage you actually to go back and watch, particularly Paul's presentation again. The recording's really good, and it will really help you to remember that framing in terms of the context. Similarly with Chuhua. For the other 2 sessions, I have recorded both the main session, the short presentations made by myself and Sean, and also the feedback, where there's actually much more richness in the conversation. And we've got both the recording and the chat. So if you did miss any of those sessions, or if you want to go through them again, they'll be available on the chat. Which brings us to today. We've really delighted to have Martin and Alex with us to run their research software carpentry training. They'll tell you a little bit about the objectives of the day in a moment. The one thing I want to say at this stage is that Martin and Alex are part of a team at Leeds who are embedded into the CDT. So we do have some resource available to call on Martin's team. Martin, do I say Martin's team? I assume it's Martin's team. Looks
the
like
team. The research software engineering team, or research computing more widely.
Yes.
But so we're very flat structure.
Yeah. So basically that group of people who are available to support you when you're thinking about research software. So and that's true for the students across all 3 sites, because we've got the costing for that is embedded at Leeds. You can call up and ask for advice anytime. If you actually want any sort of substantive help or long bit of time, Martin and I will just coordinate that. But basically there's resource available. Martin can tell you about that. So Martin and Alex, just before I hand over to you, I just want to check in with everybody and make sure there's any other questions, not about today, which I'm going to leave you to talk to Martin and Alex, but any other process questions or issues, if you're happy. So I'm just going to whip around the group. The new person online today is Andy Peel, who's in the same place as me, who's going to join this session because it has relevance to some of the work he's doing. So I'll get you all to introduce yourself in the order that I can see you. Hannah, so just tell Martin and Alex your name and whether you're, where are you sitting physically and whether you're a CDT student or a whatever you are. Hannah Robinson, sorry.
I'm Hannah. I'm usually at Leeds, but at the minute I'm in home in Newcastle.
Excellent, thank you, Hannah. And Hannah is one of our CDT students, one of the wiser students. Jamie, you come next on my screen.
I'm sitting in a very small room in Oxford. I'm a part-time professor at Leeds.
Thank you, Jamie. Grace? You're muted, darling.
Okay. Hi, I'm Grace from Sunny Rodley in Leeds. I'm Leeds CDT.
Thank you very much. Mofwe comes next on my list.
Yeah, I'm Mofwe from Leeds and I'm aligned to the CDT.
Yeah, so Mofwe's in his 2nd year of his PhD, he's a bit ahead of the others. Rebecca?
Hi, I'm Rebecca. I'm a Loughborough CDT student and I'm currently near High Wycombe at my parents' house. Yay!
Richard? Richard's poorly, so he might sound quite gravelly.
No, I think I'm all right. So yeah, I'm Richard. I'm at WEDEC, so obviously Loughborough. And I'm not in Loughborough itself. I'm in a little place just outside East Leek. So yeah, nice to meet you.
And Richard's also a CDT student.
Oh, sorry, yeah.
Freya?
Hi, I'm Freya. I'm a bit complicated. I'm a student at the University of Technology, Sydney, but Barbara is my co-supervisor, and I'm currently based in France.
Excellent, thanks Freya. Hannah Ritchie.
Hi, I'm the other Hannah. I'm a CDT student at Cranfield, and I'm in Cranfield at the moment.
Thanks, Hannah. Harriet? Harriet, you're muted.
Hi, I'm Harriet. I'm in Leeds and a Leeds CDT student. Currently sat on my floor, which is why you can see my nose.
Andy?
Hi, I'm Andy Peel. I'm sat in Macclesfield, Cheshire. I am a water and sanitation consultant.
Thank you. Alan?
Hi, I'm Alan. I'm the third and final Loughborough student, and I'm still in Loughborough.
Well played, Alan. Thank you. Jonathan?
Hi, I'm Jonathan. I'm in Leeds, and I'm part of the CDT.
Excellent. Sophia? Sophia, you might be muted and we can't see your video.
Yeah, sorry, I'm a bit trouble with my daughter. That's why I'm not showing up.
Oh, no problem at all. Don't worry.
I will show up in a bit. Just
okay.
For a minute. I am Sophia. I am a CDT student at Cranfield. That's it. I will show you up.
Thank you. Yeah. So and Leonie.
Hi, I'm also with the CDT in Leeds, currently in London. I will also switch on my video a little bit later.
Okay, thank you very much. So Martin and Alex, you'll understand that we are very EDI compliant here. We have a large number of small members of our team who occasionally need to be sorted out in various corners of the world. So if everybody's happy and knows what's going on, it's my very great pleasure to hand over to Martin and Alex, who can introduce themselves to you and take over the day. I'll just be loitering if you have any problems, Martin.
That's fine, Barbara. You loiter away there, don't you worry about it. If you start, if things fall on you or anything like that, we'll keep an eye out. Right, so hello, good morning everybody. So as Barbara said, I'm Martin. My colleague over there is going to introduce himself in a moment. Is Alex Coleman. And in fact, I'll let Alex introduce himself first, and then I'll introduce me and talk about what we do today.
Hello, everyone. So yeah, I'm Alex Coleman. I'm a research software engineer in the research computing team, as Martin's mentioned, at Leeds. My background is I actually did a PhD in molecular virology, which has suddenly come into fashion again. Although I didn't do anything on coronavirus, so please no coronavirus-based questions. And then I did some sort of data science work, which covers some of the stuff we're going to sort of touch on today. We're going to be looking at using R, which is a really powerful statistical and data science-based language. And I sort of sit in the research software engineering team doing training with Martin, and also sort of thinking about some of the more machine learning and data science style stuff that we do as well.
Absolutely. And Alex has been with us since last October, I think.
Indeed.
Indeed. There we go. Excellent. And I'm Martin Callahan. I've been with research computing in its various forms at Leeds for getting on for 7 years now. I've done loads of other stuff in the past. I'm very much a jack of all trades and master of none. I think that's the best way of putting it. And what we're going to take you on today is a little bit of a journey, primarily into reproducible research, I think, more than anything else, which is a key driver these days for many funders, particularly in terms of the sort of numeric, statistical and mathematical, analytical parts of your research. Very many of you will probably have used Excel quite a lot for data analysis. Might have worked out that it's really hard to reproduce anything that you do in Excel, even yourself the day after. And what we're going to introduce you to is a language that's used, as Alex says, very, very widely across all sorts of data analysis. It's called R. Just a little hands up. Has anyone heard of R before? You know the little yes and no buttons, don't you? Do you know the little yes and no buttons, and put those on? So if you've heard of R, stick your hands up. Little green hands up. If you've never heard of R, let's see some hands up there. A couple of people. And okay, so I think 50% of people have. A few people admitted they haven't, and everyone else is very non-committal. That's all right. Don't worry about it. Of those people who have heard of R, who has used R before? Ah, good. That's excellent news, that, isn't it, Alex? Because
that is.
We get to start right at the very beginning, which is really cool. Now, most people who use R will probably have it installed on their own computers, or they'll be using it perhaps on one of our high-performance compute services at Leeds, and we might talk about that towards the end of the day a little bit. But because installing and supporting software on goodness knows how many different people's computers would be an absolute nightmare today, what I propose we do is you sign up to this service called rstudio.cloud, which lets you do everything that we're going to need to do in your web browser. Yeah, means there's nothing to install, and we sort of just get going really quickly. So very broadly, what we're going to do today. So I'll run you through this. I'm not writing any of this down, so we're not going to be held to it. The only thing I will hold us to are the breaks, because breaks are really important. So you can go and have a lie down with a bag over your head somewhere. That's all good. We'll be keeping to the breaks. So Alex is going to start off in a couple of minutes with a sort of 35, 40-minute introduction, very wide-ranging introduction to what R and RStudio are all about. I'll pick up then and we'll start to look at how we do this data analysis in R, looking at some of the core features, functions and ideas up to about 10:40 or so. Then we'll have a break for about 20 minutes and we'll give you a little bit of homework to do during the break. We'll then take the 11 till 12 o'clock session. That's going to be me again, delving even more deeply into some of the core ideas of R and how we store and manipulate data. Alex is going to take the session after lunch, so we'll take an hour for lunch, 12 till 1. Alex is going to talk about plotting, particularly producing publication quality graphics, which I'm sure will be of interest to you all. And then we're going to finish that session off with some ideas about what we term functions. And this is where we really start to get into the reproducibility ideas. And then I'll wrap up the session, taking us up to about 4:30, with looking at some of the other packages and functions available within R that let us do some data analysis, particularly some packages of functions called tidyverse, which let us do some really interesting things. So we sort of aim to finish the formal bit around about 4:30 p.m. today, which leaves us a little bit of time then if people have got any particular questions or they want any clarification, that we've got a good chance to sort of wrap things up and get everybody's head sorted by the end of the day. So the intention is that we make this a practical session, so you're going to be doing along as well, and that means that any interesting little snippets of code or anything that is more than perhaps 6 or 7 characters long, we'll throw in the chat, so you can do a quick copy and paste if things fly off the screen quite quickly. And I think what we'll try and do as well is that whilst Alex is talking in the first bit, I'll set up a hack pad, mate. So at the end of each of our little teaching sessions, we can copy and paste all the code that we've written into another little online screen that you can go and take a look at, just in case you've missed anything. Yeah. I appreciate at times some of this might go straight over the top of your head, or it might fly past your face very quickly. But please do ask if you've got any questions. Either stick up one of the little signs. You might notice you've got some go slower and go faster buttons. So if things are getting really too much for people, please do click that go slower or even the go faster, and we'll use that as an indication of pace. So firstly, any questions? Excellent, that's great. I'm going to hand straight over to Alex.
Super. Right, so as Martin's put in the chat is the link to essentially the teaching content that we're going to do today. So it's worth getting that up in a web browser as well. And then really what you need to do is go and log into RStudio Cloud if you have signed up already. And if you haven't signed up, go and do that quickly. It doesn't take too long. I will just start sharing my screen and we can start to kick off. So So this is what the schedule of the content that we're going to do today sort of looks like. I'm going to take on for the first sort of 35-40 minutes, as Martin said, on this introduction to R and RStudio, and then talking a little bit about project management in RStudio, which is again a key facet to making your work reproducible, is looking at how RStudio has a number of tools that can help you do that. So firstly, RStudio Cloud, which hopefully you've got a account on and been able to log into. If not, what I'll do, because I'm talking, I can't see those chat symbols, so I'm going to leave it to Martin to sort of eyeball what's going on. And if anyone isn't able to get up to this stage, he can try and provide you with some assistance. And then when we switch, we'll do the same thing. So on RStudio Cloud, when you start, it drops you into this area called your workspace, which has a list of projects available to you. If you've never done this before, you won't have any projects. I've been in here once before, so I've got a little test space here. But to get started, we click New Project. And what this is going to do is it's going to open a new RStudio session for us, which will essentially look like what RStudio looks like if you were to run it as a desktop application, which is the other way people run RStudio. And when we talk about R and RStudio, what we're talking about there is we have R, the language, which is this programming language, which is actually a implementation of an older language called the S language, which was invented in the Bell Labs. And it was included with some additional features and was repurposed as R. And whenever you start and then RStudio itself is a piece of additional software which sits on top of that installation of the language, which provides us with this nice interactive interface that helps us write our code. So when you log into an RStudio session, you'll have these different panes, as they're referred to. We have this console pane that's just here, which by default will tell us some information about the R version that it's running, a little bit about how we can read the license and things. And this is an interactive console where we can start typing code into an interactive development environment. On the other side, we have some panes that are to do with the environment, and it tells us whether there are any variables assigned in this environment, or which we'll come to a bit later. What are those variables? And then this bottom lower pane covers, in this case, it's showing files in my current directory, my working directory, which is the sort of folder location that all this work is currently going on in. But also you see it's got an additional array of other things. So it's got the plots, which is where it's going to output any plots we produce, a list of packages that are available in this environment, a very useful help viewer, which we'll talk again a little bit about later, and then an additional viewer pane for things that we want to render and view. So when people traditionally use RStudio, what they'll do is they will have this console window here, and they'll also, using some of the buttons up here, what they'll do is they'll create an additional script file. And essentially all this script file is a text file, which is predominantly where people will write longer pieces of code. What you can find is that the interactive console is useful for running single lines and testing things out. But actually, when you come to write longer analysis, where say you want to load data and render it into a plot, you want that all to happen in sort of one go. And therefore you write in the script file all of those steps so they can be executed in one run of code. So just to help you view from one of our previous sessions, we found that the console, which I'm going to use for this first start, is in a bit of an annoying place in your Zoom window. So I'm just going to switch those panes around quickly. Again, that's something you can do in RStudio. It's got lots of good settings. So if we do this pane layout, I can switch around my console and the source pane being where the script lives, and they swap round. So with if we're to write this is just going to be what's called a .r file when we save it. So in the first instance, it wouldn't be a proper programming tutorial if I didn't do a hello world example. So what we'll do in the first instance is make sure you've got an R script space here. You can make that by clicking this little icon here, the white page with a green plus by it, and that should open this little untitled one script file. And what we'll do, just to show you how these script files work, is we'll do a standard example where we're going to print hello world. And at the moment, this hasn't run, but what we can do is we can select this line and click the run button here, and this will run this code in R in the console and output any output that's generated out for us. So there you go, hello world, nice and easy. And essentially, what you'll find is whilst in this, as we progress through the day, we're going to start off by essentially introducing you to some of the basic concepts in R, and we're going to type them in the console. But as we move on to slightly more advanced topics each time, we're going to start to move out of the console and writing longer script files, where what we'll do is we'll run lines of code at a time, because that's not something you can do easily in the console, but the script file makes it a lot easier to do that. So as well as selecting and pushing run, you can also run by holding Control Enter. And on a Mac, I think it's the Mac key and Enter. And that's another way to run code. I think if you don't select anything and you hit run, it will run the previous selected line. But that is some of the basics of how the script file interacts with the console. So, as I said, we're going to spend this little bit in the morning talking more about some of the basic principles. So we're going to be mostly in the console. So in the console, what you can see is this little caret prompt here, followed by like your blinking cursor. And that is just indicating that anything that has previously been run has run, and it's now waiting for a new input from you. And if code is running, this little symbol won't appear.
I'm just going to dive in there, Alex. Someone's just asking me just show how to swap the two panes over again.
Sure. So to swap the panes over, we go to Tools, then we go to Global Options, and then on Pane Layout, in my case, what I did is I selected this top left-hand pane and I changed it. It was originally source, and I changed it to console. And in the process of doing that, it automatically changed source to where console was, which was the bottom left-hand. And then once that's done, we hit apply and we hit OK, and that returns us. So some of the simplest things that you can do with R is you can use the console to evaluate basic mathematical expressions. So in the console, if you type 1 plus 100, the console will evaluate that mathematical expression and return for you the answer to that expression. And this is when we're coding in consoles like this. This is what we describe as a sort of read, evaluate, and print loop. So we're going to type code in here. It's going to be evaluated by the R language, and it's going to print the result of that out in the console. And you can tell what the results are that it prints out, because immediately following the code that you've entered, and when I'm entering code, I'm using my return key to do that. It tells us, it gives us this 1 in square brackets, and then the value that the answer that's returned. And this just tells us that it's returned one line with that value. One thing that you will notice when you start to do things like this is if you hit return too soon, what you'll find is that you don't get returned to the regular cursor. In fact, what we've now got is this recurring plus situation, which can be a bit annoying. But all that's going on here is the R console is saying it's expecting another input before it can do anything. Now, sometimes you can do this by mistake and want to get out of it. We could type 100 here, and it will then evaluate it. But sometimes we can get stuck in this sort of perpetual plus loop, as it were. And the easiest way to get out of it on RStudio is to push your escape key on your keyboard. And that will return you to that original cursor. The other thing you can do is you can also push Control C, but I think on the RStudio Cloud that doesn't always work on everyone's system. So for now, what we'll recommend is you push the escape key to return to your cursor. And that can be quite useful because, I mean, this is quite a trivial example, the idea of 1 plus and then forgetting to put a value, but perhaps you accidentally run a big model and you realize you haven't set a parameter properly. You can push escape, interrupt that run, and alter those changes. And then you don't have to wait for your model to run in error and can interrupt that command. So that's a that's a useful thing to remember. So in R, I've already seen plus for using for addition. It also uses the regular hyphen or minus key for subtraction. The asterisk is the character for multiplication. And the / is the character for division. Exponentials are either with the upper caret or with 2 asterisks followed together, and that will do the same thing. You can also use parentheses to group operations to force the order of execution, and so you can do things like and this is a useful thing when you're writing long mathematical pieces of code, because you can make things easier for some people to view by wrapping your code in brackets, so that they can see which sections are doing which, and they don't become sort of long and quite unwieldy. You'll also find in R that if you create very small numbers, that it will render it in scientific notation. And that shorthand, whilst that shorthand is presented like that, it still recognizes that as a number itself. So you can still do further maths on that number. You can also write numbers into the console like this. I'm also going to put a hash here and just show you how to do comments within code. So when we see this single hash, anything following that hash is not executed as code. And that's what we call a comment, which is quite a useful way of sort of writing down what exactly that line of code does. And what you'll find often is when you go and look through other people's code, in these big script files that we referred to earlier, they will write comments, lots of comments before each line of code to sort of let you know what they're trying to do in that line of code step. And one of the things that we would strongly advocate to you as you start your sort of programming journeys is to really use comments. You know, there's no such thing as too many comments, in my opinion, in code. And I think Martin would probably echo that as well. Because this, especially in your own code, these aren't just comments for other people reading your code, they're really comments for yourself. Because over the course of your PhDs, you might write lots and lots of code. And the code you wrote at the start might look very different to the code you start to write towards the end of your PhD, but it's always useful to sort of write notes to yourself and be kind to your future self by writing out with comments the sort of what your thinking was when you wrote code like that. So these hashes are useful in that way. So if we wrote a line that starts with a hash, what we'll find is nothing is returned because the hash itself indicates to R that anything following the hash is a comment and won't be run. So that's why we don't get any output there. And that's why in this case we wrote some code before the hash and then the hash, and it just executes that piece of code. So one of the reasons why R sort of became very popular in its first instance as a sort of data science and statistical language is that built into R in its very basic format is a number of mathematical functions, which isn't the same for, say, other languages like Python. They don't have sort of built-in mathematics support. So we can call functions in R by, we have to know their name firstly. And often you might think you need to find a function to do something, like the logarithm function, and you're not quite sure how to do it, and you maybe give it a try and can't find the right answer. What we would recommend you do is just go off and Google how to do that, because actually there's a very strong and vibrant community of R users out there. And there's also lots and lots of useful tutorials about how to use R on all sorts of topics. So for things that you're not quite sure on how to do, Google really is your friend. And looking on places like Stack Overflow and also RStudio forums is also a good way to find useful help and hint and tips. But in our case, I know there are a couple of functions in here. So you can call functions like this, where we give the name of the function, we open some parentheses, and we put a value into that function. And it will then evaluate, when we hit return, it'll evaluate that function and return us a value. We can do that with log, and we can do log 10 as well. And we can also do the exponential. So the fact that these are built in is quite useful because it doesn't require us to go off and get additional packages to use those functions. And that initially was one of the reasons why people sort of moved to R in that way. With functions like this as well, I did mention earlier we've got this help pane here in this window. You can search for things in the help window to see if they're within the sort of basic R manual files that come with everything. Or you can, if you want to know more about a specific function that you're typing in, you can put a question mark before the function. Oh, that's a nice autocomplete feature there of RStudio we don't want. And if I hit return, it goes and finds the documentation page within Basic R and gives us some information about it. These are normally broken down into sort of a description of what the functions do. In this case, it's actually taken us to more broadly all the trigonometric functions in R. It then covers some of the usage, so how you would expect it to use, and then it's going to cover you know, the arguments that things are expecting, and it's going to go over in slightly more detail what exactly is sort of going on here. And at the bottom there is normally an example just to show you how to use it. So the help functions within R are normally incredibly rich in detail. So if you are unsure about how things work, and often you can, so say if I accidentally pass a string to sign, I'll get an error message because clearly that's not what it's expecting. And actually in the error message, it will tell us that it's a non-numeric argument to a mathematical function. Now that's a very useful error message, and it sort of tells me exactly on the tin what I got wrong here. But occasionally you might find slightly more obscure error messages, and that's where using the question mark before the function or looking on the help page is a really useful way of trying to troubleshoot those issues that you might come across. So there's also the useful concept within R of sort of Boolean values, true and false. And we can also start to do comparison of different values within R. So an important thing to note at this stage is that when we've been typing in is the sort of data types that exist in R. So at the moment we've been typing in what would traditionally be called strings in different in other languages, where we've wrapped a series, you know, so some words in double brackets or single brackets you can use. In R, those are called characters, and anything within quotation marks is considered a character, which is very much like a string in other languages. We then also have been typing in numbers, and in R, these will be considered numeric type values. And that is distinct from an integer value. So we can test this using the type of command, which we can look on the help page actually. And that'll determine the R internal type of an object. And this again can be quite a useful thing. So if we do type of, and we pass it hello again, it'll tell us that it's a character. If we do type of 10, it'll tell us it's a double. And what it means there is it's a double precision floating point number. And that is the same for a more traditional decimal value. So they aren't integers by default. When you pass what would look traditionally like an integer, it's actually presenting you with a floating point number that's been approximated. If you want to pass an integer in R, you need to put the value followed by a capitalized L, and that will be an integer. And that's an important sidebar, because when we start to do comparisons, as we're about to do, typically what is advised in R is when we do comparisons, that comparisons are sort of, you've got to be careful with them, because actually, as we've shown here, by default, it's defaulting to actually sort of a floating point value rather than an integer value. And so it can be what's called truthy and falsy, which you need to be careful on. But I'll explain a bit more in just a second. So you can do comparisons like so with the double equals sign. And when we do this, we're asking R to evaluate if this value is equal to the right-handmost value. And what it returns for us is a Boolean value of true. So in R, for it to be a Boolean value, true or false has to be written all in capitals, which again is not always the case in other programming languages. So it's important to note that. This is a test for equality, we describe it as. And we can also test for inequality as well, using exclamation mark equals. I'll start writing comments because I said it was important to do that, and I've been loath to do that myself. And essentially, this reads as not equals 2. Okay, so we're asking if 1 is not equal to 2, which we would expect to be true, and so it tells us that is the case. We can also use less than and greater than symbols. So we're asking if 1 is less than 2, which again will return true. We can also use less than or equal to. And I'm doing a series of trues here, but we can also, it'll also return false if the test is false. And you can also do greater than as well. So the sort of caveat that I was sort of talking about a bit earlier is this idea of in true R, what you would tend to be advised as best practice is not necessarily to compare numbers that aren't explicitly integers with that capital L using the double equals brackets. What they would recommend you do is you actually use a function called all equal, which again we can have a quick look at in the help, because these values we specify are actually approximations of floating point numbers. They might not explicitly be exactly equal, and therefore it's recommended that if you're comparing these non-integer values, you use this all equal function instead. So, and all that function does is it does the same sort of thing here, but it does it with a level of approximation and a level of tolerance, because these are two sort of approximations in the R programming language. And if you're going to use R to do very, very, serious mathematical stuff, it's important to note that that caveat now. So another super useful thing is variables. And variables are a common thing you find across programming languages, and they're a way of assigning a value to sort of a placeholder that we can refer to in the future. And we can do that with R using this arrow, which is a less than symbol and a hyphen. And that is the assignment character in R. They have to be next to each other. They can't have spaces. And that says we're going to assign to X, in this case, the value of, in this case, we're going to do 1 divided by 40. Now in RStudio, this actually updates our global environment. And you can see that what it's done is it's actually added a variable with its value in that space. And again, that's a useful thing within RStudio that allows us to keep track of all the different variables that you might need to assign. Now, this is a very useful thing within programming languages. It allows us to store values within a placeholder. In this case, I've used X, and we can then do all sorts of additional things to it. So we can run functions on X, and what X will then pass to the function is its value, which in this case is 0.025. And with this level of sort of abstraction, you can start to build quite powerful tools. We can also do things like if we reassigned the value of X to being 100, we could then do reassign the value of X to X plus 1, and it will update the value of that variable. We can also assign new variables based on the value of another variable. And again, you can see that updates in the environment as well. So when you're making variables, and in my example, I've used X and Y because it's a nice explanatory example. But what we recommend, again, to make your work as reproducible and as readable as possible, is to come up with a consistent naming pattern for your variables. So whether that's using full stops between different words to describe what the variable is, using underscores, or using camel case, which is where you start with a lowercase and any new word begins with an uppercase character. It's important to really name your variables in a way that both reminds you what they're actually all about and would remind someone else what they're about as well. And very, very quickly, just to sort of wrap up, vectorization is another really powerful thing that's built into R. And that's this idea of vectors, which is a data structure in R, which is essentially a one-dimensional array where all the contents of the array are the same data type. So if we do 1:5, it will produce for us a range of numbers from 1 to 5, and it outputs this as an array, as it would be in this case, an array of of numeric values in this case. And with arrays, you can start to do useful things. So we could assign X to being this array. Oh, helps if I type it properly. And now you can see that here, there's an array there. We could then do some maths on that array and raise all of its values to the power of 2. And you can start to do very, very useful things with vectors in this way. I keep saying array because I come from a sort of Python world, but vectors allow us to contain values of the same data type and pass them and transform them in a very useful way. And I think, Martin, this is the time where I'm perhaps hand back to you.
Excellent. Right. Okay. So that was a massively flying visit through a whole bunch of sort of underpinning concepts and thoughts. In fact, have you got? I've got my microphone plugged in. There we go. Concepts and thoughts. That might be better. You might be able to hear me now. So I think this might be a good point. If anyone's got any questions, any bits of clarification they want to ping in the chat, and we might just have 5 minutes to deal with those before we move on to look at something else. So Jonathan's asking, is matrix algebra as straightforward as vectors? Yeah, basically. That's not problematic. The notes that we're not going to get through every single element in the notes. There is a sub-chapter in the notes about dealing with matrices specifically rather than vectors. So that is definitely something that R handles quite easily, quite well, in much the same way that you've seen Alex dealing with these commands. So yeah, no problem with that. And everything that you would expect to be able to do with matrices as well is inherent. So anything else from anybody? No, we're all very quiet. Shell-shocked, Alex. What have you shown him?
What have I shown him?
What have you shown him? Right, okie dokie. Let us move on. So just give me a minute or two just to rearrange my screens. So I'm just going to mute myself for a second. I'm going to get everything.
I'm just going to chip in while Martin's doing that and just remind everybody, we all know that you're in your houses, stuff's happening. If you need to step away, let the dog out, shout at the children, all those things, as we've always said before. Shout at your husband, shout at yourself. Any of those things are allowed. So just don't worry. I'm sure Martin and Alex have had lots of experience of running online training. So please don't worry about things.
Yeah, don't worry at all, folks.
Oh, absolutely. If the postie knocks on the door, I will nip off and have to answer. So don't worry about that. These things happen. We've not got the eye tracking. I don't think Barbara's got the eye tracking set up on Zoom where we're actually checking that you're paying attention. So
I know, but I record everything, and then I spend all night and forensically going through the videos just to see. No, I don't. That's a fib.
Yeah, not even in jest, Barbara. Right. Okay. Source console. Right, I think I'm pretty much ready to go. Yep, I am. I've got everything set up there. Hang on. Let me rearrange some windows. And hopefully I'm going to jiggle a few things around. I'm going to make my font a little bit larger. Only that you might find it a little bit easier to see. Okay, that's good. Right, excellent. Let's crack on. So one or two little points about organisation, I think, more than anything else. If you recall back over here in this sort of multi-use quadrant of our screen, at the moment, the tab that I've got activated at the moment is my Files tab. And it shows the files that I've currently got in my current project, Waterwise 2020, I've called mine. One of the things that we find really useful, folks, is to do a little bit of organisation. So we've got a sort of top level folder for our project. It's really quite useful if we stick some extra folders inside there, perhaps one or two little files as well, so that every new project that we set up for every new part of data analysis, we always have the same structure. We know what we're trying to do, but more to the point, other people have got a fairly good idea what we're trying to do as well. So instead of just chucking everything into that same folder and hoping for the best, we're going to create a few subfolders and use that to put in different types of file. So you might see there's a little button there called New Folder. You see that? So I'm going to hit that New Folder button, and I'm going to create one folder called SRC. I'll explain what these are for in a minute. Another folder called Docs, and another folder called Data. So 3 folders into my SRC. So SRC is short for source files. That's where I'm going to put my R scripts. Second one, Docs. I'm going to put any documentation I create in my Docs folder. And then any of the data that I'm going to use or indeed generate is going to go in the data folder. So I'm trying to organize my project. So we very often meet people who come to us with their problems, and literally they've got the whole of their PhD research in one folder. many, many hundreds, or in some cases thousands of files with no idea about how they were named or when it was generated or what they do. And it's a bit of a mess, isn't it, Alex?
I mean, they often claim they have an ingenious file naming system that makes it very easy for them to go through this folder of sort of 2 million files and identify what they want. But I don't believe them ever.
No, I think they're kidding themselves. So, so we're going to help. We're going to help you by helping you organise yourselves. And we would suggest that this basic structure for an R project of SRC for your scripts or your source files, we call them. Docs go in your documentation, and data goes in the data folder. Okay, so let's move on a little bit. So I'm heading into our lesson on data structures, and if you want to have a follow along with me, I'm going to pop that link directly to the lesson that we're looking at in the chat now. So it's the lesson called Data Structures Part 1. And what I'm going to do is firstly set up a new R script file. Now, again, a little bit of organization here. At the top of any R script file that I write, I put in 3 comments, okay? I put in what is essentially a heading. So this is a bit like primary school. Do you remember when you first went to primary school, taught what to put at the head of your page? Now, it also helps if you spell properly. And talking and typing is never a good thing. So I put a little heading at the top, what it is I'm trying to do. I put in a little line about who wrote it, so the author. And I always put in the date as well. Oops, sorry. And because I pretend to be a computer scientist sometimes, I use this particular format for the date. What is today's date? See, I've completely lost the plot. 21st?
23rd, isn't it?
23rd, 23rd. There we go. So it's April the 23rd. Okay, so that's what I've done. So a couple of other things have happened here. Firstly, you might have noticed, if you're following along and doing the same thing, that in this little tab here, the name of the file, which I didn't give it a file name, but it's changed to red and there's a little star, little asterisk by the side of it. So that means that there's an unsaved change. So the first thing I'm going to do is I'm going to save it with a new file name. Now it says save as, that's what I want to do, because I want to give it a name, but also I want to save it in my SRC folder. Okay, that's where it's going to go. And I'm going to give it the name 01 underscore data underscore structures dot R. So that R is the file extension. So this is a naming convention I use when I'm teaching. I start my file names with a number, and giving myself 2 numeric positions there allows me to have anything from 00 up to 99. And then I put in an underscore to represent a space. Spaces are bad in file names, don't do spaces. And then a suitable name for it, so data structures in this case, because that's what we're going to look at. Okay, so 01 underscore data underscore structures dot R. I click on the SRC folder and I click save. Got a file name up here. Now, unfortunately, that didn't end up in my SRC folder because I don't think I did the right thing at the right time. But what I can do is I should be able to move it. Yeah. So can you see what I'm doing there? I inadvertently didn't save it in SRC. So I've ticked the little box by the side of it, go to the more little gear wheel, do move, and then where do you want to move it to? SRC. Okay, double click, that's where it ends up. Perhaps that's what I did wrong last time. I didn't double click SRC. Click choose. It says, oh, you've moved me. So I'm going to click yes. Go back to my SRC folder. Well, there it is. If I want to open a file that's already there, I can just click it once and it opens. So I made a accidentally on purpose mistake there to cause myself an error that I needed to get out of. So that's how we can move files around. And move is different to copy. So move takes it to one place, puts it in another. Copy creates a duplicate. Okay, so that's our file. And the whole premise of this introduction to data structures is that we're going to talk about how R deals with tabular data. And that's how most of us get quite a lot of our data. It's in a table, it's in a spreadsheet, or in a CSV file. So what we're going to do is we're going to create some tabular data. We're going to do this programmatically. So that means we're not going to just type it into a spreadsheet. We're actually going to make it using R, which is going to introduce a few more functions to us. So I'm going to do a little section here, and I'm going to call this one creating tabular data. So I'm going to create a thing, and a thing is called cats. Now, it's going to store some data about some cats, and we'll look at what this actually does in a moment. So I'm creating a data structure that R calls a data frame. And to all intents and purposes, a data frame looks a little bit like a spreadsheet, but it's got some unique characteristics, which we'll talk about in a moment. So my cats data frame is going to contain information about 3 cats. So it's going to have 3 rows. And for each one of those rows, it's going to have 3 variables. So 3 observations, 3 different cats, and 3 variables. So I'm going to hold some data about the cat's coat, colour, in other words. I'm going to hold some data about its weight in the second column. And I'm going to hold some what is essentially Boolean data, true or false data, about whether or not that cat likes string in the third column. And once I've generated this thing, this data frame in memory, I'm going to write it out to disk. Okay. So the data frame is R's fundamental structure to hold tabular data. I'm going to give this data frame a name, cats, because again, as Alex said a moment ago, giving your things meaningful names is very, very important. So let's see how we create this thing. So I'm going to create the coats column first of all. Okay, so lots of brackets going on there. So cats is the name of the data frame. Data frame is the command that generates this thing called a data frame. And here's the first column, coat. Now this C command here, this C operator, is actually short for concatenate, which means join together. So we're going to join together or create a column. I like to think of it as a column. We're going to create a column called coat with the entries calico, black, and tab. So we're building up columns side by side. So next to the coat column, I'm going to create a column called weight. And again, I'm going to concatenate some values together. Now, we're assuming that these are in kilograms. So there are 3 entries here. Like so. So there's an entry 2.1, row below 5, it's quite a fat cat, 3.2 in the third one. So that's my coat column, weight column.
Just big boned
I'm going
mine.
to stick a like string column. Alex?
Just big boned mine, not fat.
Not fat. Fat cat. Big boned. There we go. Don't want to be I don't want to be cat shaming, do I? So like string, and I'm going to have some values 1, 0, and 1. Whatever 1, 0, and 1 mean. So there we go. So that's how we generate a data frame. Now, nothing's happened yet because I need to execute that code. So I'm going to shade it all up, and I'm going to hit my little run button, like Alex showed you before, and take a look at what's going to happen over here in my global environment. So there we go. So I've created this thing now called cats. Something happened down in the console to execute the command, and the global environment, what is essentially R's memory for this session, now contains this data structure called cats. It consists of 3 observations of 3 variables, 3 rows, 3 columns. And you might just see right at the end there, there's a little, what looks like a little spreadsheet symbol, a little table symbol. And if I just click on that, pop, it actually shows me what's in that data frame. So those are the column headings, coats, weight, and light string. There are the values that I put in my code, and it's conveniently given me some row numbers as well. When I save it, I don't want the row names, the row labels. But that's what I'm going to do now. Is I'm now going to save this to disk. Now, saving stuff to disk, saving data to disk as a permanent record is actually quite a good thing. It is a very useful and in fact sort of best practice characteristic. Actually with R, you can sometimes get away with not doing that. R is very good at saving the state of everything that you've got in memory at any one point in mind, but probably not something I would advise. So let's have a look at how we do that. So I'm going to write that file. I'm going to write it as a CSV, a comma separated variable file. And the write CSV command requires a few bits of information. So it wants to know what it is I'm saving first of all, which is the X parameter. So I want it to save cats. I need to tell it where I want to save it as, and that's the file parameter. And I need to tell it that I need to save it in the data directory as felinedata.csv. So note there's no spaces in that file name. And remember I said I don't want those row labels. I don't want that 1, 2, 3. I want to switch those off. So I add an extra parameter here, which is row names, to be false. Okay. So I can now run that line of code. Got an extra space in there for some reason. Run that line of code. And what I should have found, well, something clearly happened. Let's go and see whether I've got anything in my data directory, which I do, felinedata.csv. Let's just click that and see what happens. I click it, I get an option to view file, and up pops another little window, and here is my comma separated variable file. So the CSV file is what's stored on disk, and the data frame itself is how R reads in that CSV file and stores it in this thing called a data frame. Now, we've chosen CSV files because that's very often how data is supplied to you, how it can be exported from other programs like Excel, and how a lot of experimental equipment, laboratory equipment, might actually produce data too. But we're not limited to just CSV files. We can read in Excel files directly, for example. Okay, so that's tickling away quite nicely. Every so often, it's probably a good idea just to hit the little save button, just so I know that my current thing's been saved. I've got some data in memory at the moment. So if I was starting a new session, and I'm going to simulate starting a new session by removing cats from memory. There's a nice little command called rm for remove, which lets me take out data and data structures from memory. So if I remove cats, let's just do that. Hopefully what we should see here is that disappears. Let's see. There it is. My environment's empty. R now knows nothing about my cats. So if I was loading data in from a CSV file, I would say create cats from reading a CSV this time. And I tell it what file I'm reading from. So file equals data, then a little slash. I'm just going to type in the first couple of characters and I'm going to hit tab on my keyboard. Notice because it knows what's going on, it can read that in. So I didn't have to type that in. R did what we call tab autocomplete to go off and find the real file name for me. If there were several files that started with FEL, it'd give me a choice, a little picker to choose them from. Okay, so now that's read that in again. And if I want to display it in my console, I can use the name of the data frame. Let me put a little comment in for you there. And run that single line command. And there we go. Coat, weight, light string, and I get my row numbers back this time as well. So we've had a look there at creating tabular data from program code, looking at how that is stored in the environment, in the computer's memory, writing files out to disk, removing data structures, and then loading them in at the start of our session. So they're the sort of activities that you might typically do at the beginning and at the end of an analysis. And of course, all the other stuff that goes inside, in between, is what we're going to be touching on during the course of today. So let's learn a few more things about data frames for the next quarter of an hour, 20 minutes or so. So let's explore our data set. So we can look at columns. So that's the first thing. So our data set conveniently has got 3 columns: coat, weight, and light string. So if I just want to look at, let's say, the weight column, so I would say cats $weight allows me to have a look at just one column. So what this will do is it will extract a vector of those 3 values. So 2.1, 5, and 3.2. If I want, for example, the coat column, it's cats $coat. There we go. And this time around, it tells me I've got calico, black, and tabby, which I knew, but it's also told me something else. It's identified that this is perhaps a special type of data. It's had a good guess, and it thinks that these are categories or categorical data. So it's not treating calico, black, and tabby necessarily as just plain old text. It thinks that these are categories. And actually, R's really good at guessing this. And in this case, calico, black, and tabby are categories. And the way that these are represented and the way that it permits us to do some statistical operations on these categories is really quite useful. It's much easier, for example, to do counts across categories than it would be to do counts across text. But anyway, so that's how we can pull out columns. We can do operations on those columns as well. So we can do maths on the columns. And let's say the scale was weighing 2 kilograms light. I think if that was the case, we've got a lot of very big bone cats, haven't we? So we can do an operation on the weight and add 2 kilograms to it. So what this means is that I do the same operation on every element in the column, every element in the vector. And this is what Alex was talking about before, this whole idea of vectorized operations. So in some older programming languages, I'd have to take each element one at a time and do weird stuff with loops or something even more complicated in order to do the same operation on every element in the set. I don't need to do that. R works out how to do this sort of under the bonnet. You don't need to worry about this. If you need to do the same operation on every item in a vector or a column, we can use R's built-in vectorization operations to do this. Now, in our case, we're only doing this on three elements. But whether it's 3 or 300,000 or even 300 million, I was not really bothered. So I'm going to add 2 to the weight. There we go. Down here in the console, you'll see that it's changed that to 4.17 and 5.2, adding 2 to everything. What this hasn't done, though, is changed anything on disk. And that is quite key as well. So we've only changed what we have stored in memory. If we need to change what we've got stored on disk, we would need to overwrite that data. So let's look at a few more vector column operations. I'm just going to give myself a little bit more room. We could do this, for example. Here's another one. So this takes the string, my cat is, and sticks that in front of everything it finds in the cat's coat column and prints the message out 3 times. My cat is calico, my cat is black, my cat is tabby. So paste works a little bit like print, but what it allows us to do is join together several things. So paste generally does mean sort of cut and paste together 2 things, the text my cat is with whatever that generates. Let's try this one. So question for you then, or any of you guys, what do you think that's going to do? Just pipe up, you can unmute yourself and just shout out on that one. What do you think that's going to do? Any thoughts?
Is it going to bring back an error because it's trying to add kind of different types because it's numbers and then codes?
Absolutely, numbers and text. Yeah. So thanks for that, Hannah. Yeah, it is going to give me an error because it's trying to do an operation, and a plus operation here on 2 completely different data types. Something numeric out of the weight column and something textual out of the code column. And although programming languages are quite clever, they don't know what's going on in your head. It doesn't know whether you want to try and do a numeric addition or a concatenation or joining things together. So it just goes, I don't know what you're on about, much like this. So if we run that, I get this error message. And it says that plus is not meaningful for factors. What it's essentially saying is, I don't know how you want me to interpret the plus symbol, numeric addition, for these factors, these categoric values. So yes, I get an error message. So having a bit of an understanding of data types can be quite important. So let's take a look at those again. So we'll use that type of function that Alex showed you before. So we're going to do type of cats $weight. This tells us hopefully what we're expecting is that it's double precision floating point or real numbers. And that's exactly what's in the weights column. That's fine. That's what we'd expect. There are 5 main data types in R. They are these. More typing. Double, which is double. Real numbers, integers, complex numbers, logicals, which are the trues and falses that you've seen before, and the characters that we've been dealing with as well. And everything else, you know, is built up out of those. Remember that Alex showed you a little while ago about how to force a number to be recognized as an integer. Can anybody remember what we used to do that? Forcing an integer?
Capital L.
Capital L is the one, spot on. Thank you very much for that, Andy. So if I wanted to say what was an integer, I would do type of, say, well, if I do type of 1, for example, on its own, that's a double. But if I want that to be recognized as an integer, I stick an L. Historically, I think the L, and Alex might have better recollection here, I think the L comes from what it used to be called, which is a long integer, rather than a short integer, which is essentially how much memory is used to store the number. But
I think that's right, yeah.
I might be wrong on that. And we can do the same thing with other types of number as well. I'm not going to go through those. Right, I'm just keeping an eye on the time. Yes. So who was it that asked about matrices, by the way? I can't remember who that was. Well, if you're on the same, it's Jonathan. If you're on the same lesson as us now, about 3/4 of the way down, you'll find a little section on lists, and then a little bit further than that, you'll find a little section on matrices as well. So we're not actually going to go through each of those, but there is a little bit of reading to have a look at there as well. So I think it's time to have a look at a little challenge, a little exercise. So again, you're going to need to have a look back at the lesson notes. I'll give you 5 minutes or so to have a look at this. So we're in the data structures lesson. So I'm going to put that link back in just in case that's disappeared off people's heads. There we go. And I want you to find challenge 1. I'll give you 5 minutes to have a go at that. So challenge 1 and you're going to have to do a bit of reading and a bit of investigation here. Sorry, that's scrolled well off the screen. So giving you quite a complex problem here. There's 3 or 4 steps to do. So what I want you to do is to work out what you can do and then have a little bit of reading and see if you can do the other bits. as well. So I've identified. Start by making a vector with the numbers 1 through 26. Okay, multiply that vector by 2, and let's see. This is a sort of more advanced bit. Give the resulting vector the names A through to Z. So each position to have a name as well. Okay, so I'm going to give you, how long should we give them, Alex? I'm going to say 8 minutes, which will take us to 10:35. Okay, so 8 minutes to take us through to 10:35.
And Martin, just for the record, I'm going to leave the recording on. Are you going to have a break anytime soon? Because I do find it helpful to stop.
So what we're going to do, Barbara, we'll do the break through to 10:35. We'll come back and review the answer to this.
Yeah.
And then we'll take a break for 20 minutes.
Cool. Okay, so I'll keep the recording running till then.
And then we'll come back in at 11.
Yeah, perfect. Thanks, Martin.
Okie doke. So you've got 7 or 8 minutes now, folks. Come back, review this, and then we'll have a break for 20 minutes. Whilst you're doing that, I'm going to go get a glass of water. Oh.
So Martin, according to Stack Overflow, the capital L suffix is used because R already uses I for imaginary numbers and complex numbers,
right.
and therefore capital I would be too similar to that, and also because they're 32-bit long. So yeah, you were right.
Logins. Yeah.
Yeah.
Right, another 3 minutes, folks. Okay, I think we are just about ready to get back. Hopefully everybody's back in the room.
So we just got a question from Hannah. I'm just going to pick up in the chat, Martin. So yeah, so we can view the tabular data for cats when we click on it, say in the sort of global environment section. But for vector arrays, it won't open a new pane. It will just show you sort of a summary of the vector in that global environment section, and that's just because it's a sort of a one-dimensional data type, so it doesn't sort of render it out. You can still print it to console though, in the same way that Martin did with cats, by calling X in the script. It's just because it's like a 1D data frame, and therefore it doesn't render it in the viewer.
Okay, shall we take a little look at this at this potential solution? So what we're trying to do here really is join together quite a lot of the things that we've done so far. So if we're going to create, well, in fact, you mentioned X, so let's use X. So we're going to make a vector. Now, Alex did one a little bit earlier on this morning with values. What did you use? 1 to 5, Alex?
Yes, 1 to 5.
So if I want the values 1 to 26, I'm going to do it like that. So the colon is this auto generator, and it'll generate a vector from a start value to a finish value, in this case with 1 in between. So if I now execute that line, so this doesn't appear in my data section, it appears in my value section, and I don't get a little symbol for that nice viewer. Okay, so it tells me that it's 26 integers with the values yada 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 all the way through to 26. Okay, truncates it for me, only gives me the first few. So that's the first bit. If I then want to multiply every element in that vector by 2, I do this. Now this is something that we see quite a lot in many programming languages. And perhaps the best way of explaining what's going on here is to say the new value of X is the old value of X times 2. So the whole right-hand side gets evaluated first, and then the result gets stored back into the place it came from. So it looks like it's doing something a bit weird, but essentially it's overwriting the old value with a new value. Now, you might notice as well that I've done a couple of different types of comment here. I've got comments on their own, on a line, and I've done what I've called an inline comment down here. I can stick it on the same line as a line of programming code. And I was bright enough to understand what I'm trying to do there. So let me run that one. Take a look at what's happening over here. 2, 4, 6, 8, 10. That's what I'd hope to get. So that's a vectorized operation. And then what I want to do as well is something that's perhaps a little bit odd, but I want to assign each one of these values, these 26 values, a letter. So essentially to give them a label. Now, there is already a built-in vector in R called letters. It consists of the letters A through to Z. And what I want to do is I want to label 2 as A, 4 as B, 6 as C, etc. And I do it like this. I use the names command, and it means name whatever's in X and name them with whatever you find in letters. And let's run that and see what we get. And this time, I don't see what the names are, but it tells me that it's named this time. If I were to perhaps have a look at that down in my console, hopefully you can see that each one of those positions has been labeled with a letter. Here's something for you to try during break. because we're going to go for break now for 20 minutes. So what happens if X has more or fewer than 26 values? So that's something for you to have a little think about during break. Okay, so what happens if X is more or fewer than 26 values? Okay, so go off and make yourself a cup of tea, feed the cat, whatever it is you do, and we'll be back at 11 o'clock on the nose to have a little look more on data frames for about another quarter of an hour, 20 minutes, and also to have a look at some other useful things that we do programming-wise, building up our repertoire of skills to look at loops, repeating stuff, and also making choices with if statements as well. Okay, so if you've got any questions during break, pop them in the old chat, and we'll either pick those up during break or when everybody's back at the ranch at 11 o'clock. Okay then, see you in 20 minutes.
Thanks, Martin. I'm just going to stop the recording.